Greetings of the day. We are now in the topic transportation models for the subject operations research technique. In this particular unit we have covered first part, that is assignment problems, assignment models, where it was one-to-one assignment of the given data, available data from the person who want to optimize their objective function. And in last lecture we have seen what are the requirements for transportation model, transportation problem, and why transportation models are important in industrial scenario. We have seen that industries manufactured various products at different locations, and those products are to be transported to the end user via available means. So the intention in that is to minimize the cost of transportation. I have said in my earlier lecture that objective function may be minimize transportation cost, or vice versa. If I am running transportation industry, my objective function will be to maximize the profit. Students, if you know that in assignment problem we have converted maximization type of problem into minimization type of problem, same we will be doing if we come across maximization type of transportation problem, and we will be converting that problem into minimization by adopting the same logic as we did for assignment problem. So now here in today's lecture I will explain you the transportation matrix, details of transportation matrix, and the various methods for finding initial solution to the transportation problem, followed by how to optimize the initial solution and how to terminate transportation algorithm in the end. So we'll see those aspects step by step. So now we were at this point, I have ended my last lecture with this slide, and I assured you that I will explain each and every meaning of the term involved in this particular transportation matrix. So if you recall my earlier dialogues, what I have said, in case of assignment problem we need to have assignment matrix in a square form, which is not the requirement for transportation models, transportation problem, but transportation problem must satisfy one important condition, that is matrix has to be balanced one, balance in the form of supply and demand. Total supply should be equal to total demand. So now this is the structure in general category, this is the structure of the transportation problem. So rows will be, here it is written in the same cell from to, so actually it is from and it is to. So rows runs from row 1, row 2, row 3, row 4. If you recall my dialogue, this will be origin or factories. So factories will always supply S1, S2, SM. So factories will supply, and this is the quantity A1, A2, AM. So M is for mth row, A1 is for first row, A2 is for second row. How to interpret this? Suppose a company is producing some goods at different locations in the country, and let's assume that the company is having one of the factory located at Mumbai. So Mumbai, suppose we represent by S1, so maximum supply from Mumbai, which is labeled as S1, will be the quantity A1. For the same company, if one factory is located at Chennai, so Chennai is represented here as say S2, so maximum supply from Chennai will be A2. So supply will go row wise. Understood? Now from origin to will always be related to destination, where the commodities will reach from factories. So suppose for example we write here Bombay, and I write here from Bombay to Nagpur. for example, to explain this concept. So now this we have seen that Bombay is supplying maximum A1 and Nagpur is demanding some quantity labeled as B1. Column runs, demand runs as B's, supply runs as A's, suppose. So B1 is the demand from Nagpur, and now Nagpur is interested to get only this demand B1 satisfied from whatever source that demand is satisfied. Maybe from S1, S2, Sm. He is interested only in satisfying the demand. The transportation matrix will decide how to fulfill this demand of Nagpur from various S1, S2, Sm. That is the general theme. Now here you can see one variable x11. This is marked x11. First one stands for first row, second one stands for first column. So 1 1, here 1 2, it is written 1 2, so row 1 column 2. So write row 1 column n, 1 n is written. So this x represents quantity. X represents quantity. So out of total supply from Bombay, which is labeled as A1, X11 will be delivered to Nagpur, suppose. And suppose I am writing here, say Delhi as a second city. So X12 quantity, again this is quantity, will be reaching to Delhi. That is the meaning of, whenever there is x parameter, x represents you the quantity. X represents you the quantity. That should be very clear. We should be very clear before we start entering into details of transportation matrix. Unless and until we understand all these symbols, further understanding will be difficult. Now I have mentioned that x is the quantity. Here you can find other variable as C11, C12, C21, like that. So C stands for cost. C stands for cost. So cost of transporting one unit from source I to destination J. Suppose it is Cij. So now C11 means cost of transporting one unit of product out of this X11. X1 may be more than one. X1 may be 100, maybe 500, maybe 1000, maybe 5, maybe 10, depending on the location. So to transport one unit of that product from this location to this location, cost will be C. Similarly, C22 means cost of transporting one unit from source S2 to destination D2. Likewise, cost of transporting one unit from source M to destination 2. That is the meaning. So this is in general how one should read transportation matrix. I think it is clear now. And here at the end, this quantity, this right hand quantity, they indicate total supply from first source origin, total supply from second, total supply from third, total supply from mth. And here this B1 indicates total demand of D1, B2 indicates total demand of destination D2. Similarly, Bn indicates total demand from Dn. I think interpretation is clear now. So let's move further. Now, when we talk of transportation matrix, so it is nothing but algorithm, and this algorithm will start at one point, and the algorithm by default will terminate at one point. It will by default terminate at one point. And what is the point? Where optimality condition is satisfied. What will be the point? Where optimality condition will be satisfied. We will see what is the optimality condition. Again, as I have explained in my very first lecture, that OR takes care of very scratch beginning, and from very scratch beginning it stepwise optimize your solution. So in case of minimization type of transportation problem, where we are interested to optimize the cost of transportation, we will get one minimum value, and then we will check whether that initial value we got is optimal or not. If it is optimal, transportation algorithm will terminate at that point. If it is not optimal, it will proceed for next iteration, as we did in linear programming, as we did in assignment model. Same process of terminating of the algorithm is followed in all models of OR. Now, first we have to formulate the problem and arrange data in the transportation matrix form. In previous slide, I have shown you the generalized form of transportation matrix. So whatever the data given by your client is to be formulated, is to be arranged in transportation matrix form with proper formulation. In previous lecture, I have given you generalized equivalent linear program for the transportation problem. I have given you generalized linear program for the transportation problem, and I have explained in that particular slide all aspects of transportation problem in relation to linear programming problem. You can refer my that particular slide and discussion. Now, once we did this aspect, then important step is to find initial solution of the problem. Basic initial solution of the problem. Students, there are 3 methods, rather there are 5 methods are available. Most commonly used methods are northwest corner rule method is one, then least cost method, or it is also called as method of inspection, is second, and third is Ogle's approximation method or method of penalty. It is abbreviated in most of the operations research book as WAM method. So Ogle's V, approximation A, method M. So it is abbreviated as WAM method of finding initial solution to transportation problem. And once we find this initial feasible solution by any of the method, we will test that initial solution for its optimality. Now, this particular method I am marking by star is very important. The important meaning, you can find solution by any one method. I will insist you can also try whether what I am telling is correct or not. I will insist you to find initial solution of given transportation problem unless and until it is specified. Unless if one is specifying that find initial solution by this method, then definitely we have to adopt that particular method. It's very clear. But if it is plain solve this transportation problem, now choice is mine which initial method I should adopt. So what I am suggesting, in that scenario, always prefer WAM method, Ogle's approximation method, for finding initial solution. Now the question may be in your mind, why sir is telling like that? The reason is, if you find initial solution by WAM, it takes you very closer to final optimal solution. In some cases, that initial solution itself may be I am saying may be optimal solution, or if not, you are closer to optimal solution. So your lot of labor and mathematical calculations are saved, since by this method you are reaching closer to optimal solution. So here I have star marked that. So remember, in exam or wherever you want to apply this logic, use WAM method to find initial solution, and then you have to optimize this particular WAM solution by method called as optimality test, and it is abbreviated, that test is abbreviated as MODI method, and this MODI stands for modified distribution method. MO comes from modified, DI comes from distribution. So modified distribution method is the method for checking whether the solution, initial solution which we got, is optimal or not. Got it? So now we'll go step by step. So our first target will be to learn number 1, number 2 and number 3, these 3 methods. So we'll take one problem, and for the same problem what we'll do, we'll apply this method. I will explain the steps, so that steps will give you answer. Now, as explained in previous slides, methods of finding initial solution, and see here I have highlighted with color. These methods which I am stating are for very important, are for minimization type of problem, are only for minimization. If the problem is of maximization, in the very beginning I have said we'll convert that maximization type problem into minimization problem and we will solve it. Rest of the process is same. Interpretation, last interpretation in the form of maximization is to be done. Got it? Okay. Now we'll see for one problem all these 3 methods: northwest corner rule method, least cost method, Vogel's approximation method, one by one with proper steps. So now this is the problem. First I will explain you what the problem demands, what the problem wants, and how the matrix should be interpreted. Now if you read it, a company has 3 production facilities, S1, S2, S3, with production capacity of 7, 9, 18 units. Now see, production facility means factories. Factories are labeled as first as S1, second as S2, third as S3. S1 can produce 7 units, supply availability 7. So 9 is against S2 as given in the problem, and 18 is against S3. So simultaneously while explaining these sentences, I am marking how this is given in the matrix. Now don't get confused with this. This is very crucial. Don't get confused. Don't get confused with these particular hundreds. The meaning of this is that each unit of this product or required product, each unit, one unit contains 100 pieces. That is the meaning. Suppose that is box, means 7 boxes. Each box will have 100 pieces. That is how we have to interpret this particular data. This is per week supply is given. These units are to be shipped. The meaning of shipping is to be transported. To be transported to 4 warehouses, D1, D2. So here these are warehouses, and these are production facilities, row wise production facility and column wise warehouses. Now D1, D2, D3 will requirement of 5, 6, 7, 5, 6, 7, 14. So it has to be 6. It has to be 6, 5, 6, 7 and 14 units per week respectively. So these 5 units will contain in total per unit 100 pieces. We are not bothered now. We are not supposed to take this 100 into account, mind well. So 5, each unit of 5 will have 100 pieces. That is not a botheration. But that 5 pieces are to be supplied to D1. Likewise 5, 6, 7, 14 are to be supplied. Now here if you check 18 plus 19 is 27 and 34. So 14 plus 7, 21, 21 plus 6, 27, 27 plus 5 is 32. So here whatever given was correct in this table, this is to be modified. This is to be modified and here it should be 8. It should be 8. So now with this 5, 8, 13, 13 plus 7, 20, 20 plus 14, 34. Here again, why I am doing, I will be explaining that 18 plus 9, 18, 20, 27, 27 plus 7, 34. So now here total supply is equal to total demand. This is the Riem condition. This is the Riem condition for any transportation problem. So here it was a mistake in the problem while printing. So it should be requirement of 5, 8, 7, 14. So total supply available is 34. Total demand is 34. This is, if you recall, I have given in one slide balanced transportation problem, unbalanced transportation problem. So this is the category of balanced transportation problem. Means we are not required to add dummy supply or dummy demand in this particular case, since it is balanced one. Now once we understood this concept, let's go ahead how to find the initial solution for the same problem. Before that, what is important? The transportation cost in rupees per unit between factories to warehouses are given in the table. Now what is the interpretation of this 19? That is very important. I have explained this in previous slide. 19 means for shipping 1 unit of this product from S1 to D1, you need 19 rupees. Meaning of 30 is for shipping 1 unit from S2 to D2, you need 30 rupees. What is asked? Find minimum. So this problem belongs to objective function of minimization type category. Our intention is to minimize the cost of transportation of these goods from these sources to destinations in such a way that their supply and demand are balanced. The meaning is every destination must get what they are demanding. Every supply center must supply what they are supposed to supply. So with this balance, 34 supply is equal to 34 demand, we have to solve this problem for minimizing transportation cost. This is very important. We have to solve this problem for minimizing transportation cost. Objective is very clear now. So this particular problem belongs to minimization type, and our steps are only for minimization type of objective function. I think this is clear. And now what I'll do is I'll explain all three methods of finding initial solution for this matrix, so that we can get what I have stated in my earlier deliberation, that VAM takes us nearer to VAM solution takes us nearer to optimal function, optimal objective target of minimization of the cost. That we will be noting whether it really happens or not. So let's start. Same problem, same matrix. What I am doing? First method, north west corner rule, northwest corner rule. Now, how to interpret? Before you start finding any solution, first you have to ensure, what you have to ensure, whether total supply is equal to total demand. That we have checked. It is 34 by 34. If I cross write this, it is 34 demand, 34 supply. Done. Now students, this is talking of direction. We know that in our school days we have studied directions, 8 direction, 4 main direction, then 4 sub direction, and we know that in that direction this side is north, this is south, this is west, and this is east direction. That everybody knows. Now what this rule says, northwest. So students, you very well know that this particular direction is northwest. This particular direction is northwest. So what we have to do now is very important. Now I am explaining the method for finding initial solution to the given problem with northwest corner rule. So identify northwest cell of the matrix. So definitely this particular cell is northwest cell. S1 D1 is northwest cell. In that, check whether what is the supply. So for this particular cell, supply is 7, demand is 5. Now when the source, when particular demand center is asking limited quantity, we are not supposed to supply more than requirement. That is but natural. So now for S1 D1, I have two options of 7 as supply and 5 as demand. Will it be that I will be supplying them 7? Yes? They are not asking. They are asking only 5. So remember one thing, when you want to allocate quantity to the cell, out of that always allocate minimum quantity. So amongst 7 and 5, which is minimum? Definitely 5 is minimum. So what we will do, from this logic, for this northwest cell, what I will do, I will allocate 5 here. I will circle that allocation. And now since 5 is allocated, this is very important step I am doing. Since this 5 is allocated, no more allocation possible to S2 and S3. So what I will do, I will immediately cut it. immediately cut it. This is very important. And now since I have supplied out of 7 5, I am available with modified 2. These are important steps of northwest corner rule. Now once if your supply is more, demand is less, if your supply is more, demand is less, here you have cross of this. So simultaneously what I will be doing, I will also crossing this particular column to avoid any unwanted allocation by mistake to these cells. If, what rule says, if supply is more, demand is less, after allocating to northwest cell, proceed horizontally, row wise, and allocate in next immediate cell whatever combination possible in that minimum. So here for this cell I am having total availability of supply 2, but this D2 demands 8. So what we will do is we will supply 2 to this particular center, this 8 will become 6, this 2 will vanish, and the moment it is vanished, make habit of crossing of that particular row. Got it? Now first row, first column is over. Again our rule is northwest corner rule. One thing I will add over here, if would have to, it is like that, demand is more, supply is less, so you have to proceed column wise. That is the only difference. Now in this situation you have to identify next northwest cell. So that is this cell S2 D2. So for S2 D2, 9 and 6. 9. This is the importance of modifying, immediate modifying the value. If you don't modify value at that point of time, definitely you are going to commit mistake. So the moment you allocate any resource, any product, modify related supply and demand. So out of 9 and 6, minimum is 6. So I will allocate here 6. This 6 is cancelled. Immediately I will modify these 3. So now 6 is cancelled means I will cross this particular column also to avoid by default any allocation in this particular cell. Now 3 is remaining. So as I explained in my last row, proceed horizontal, or by default also this is the only northwest cell you are having, this one S2 D3. So here 3 and 7 you will allocate 3, 7 will be modified as 4, 3 will get cancelled. Once that is exhausted, I have said cross off that particular row or column. Now this is 4, this is 4, and for S3 is 18. So of 4 and 18, you will allocate here 4. This will become 14. This will become 14. This row has exhausted. I will cross off this particular row column. Now here you can see only one cell is remaining, and here 14 and 14 are remaining. So you don't have any option other than to allocate. Now once you allocate, cross off this. So students, now see, cross check that whether any supply or demand is still remaining. And how to cross check it? Simple. Sum up this allocation. 5 plus 2, 7, done. 6 plus 3, 9, done. 4 plus 14, 18, done. 5, 6 to 8, done. 3, 4, 7, done. 14, done. means my allocation is perfectly right. So now what is the minimum cost? Minimum cost, we may symbolize it by a letter Z. For this northwest corner rule, how to interpret that? Go row wise, we will go row wise. So first write quantity into per number of pieces 5 into 19 plus quantity 2 into 30 plus quantity 6 into 30 plus quantity 3 into 40 plus quantity 4 into 70 plus quantity, this is plus 4 into 70, then 14 quantity into 20. So students, if you multiply these values with calculator, it will give you total rupees 1015 as initial solution for this problem by northwest corner rule. Got it? So this is the method how we are supposed to find. Now we will keep these figures in mind. We will keep this figure in mind, that by first method we got 1015. Now we will see second method, and second method is, our second method is least cost method. Second method is least cost method for finding initial solution. Least cost method for finding initial solution. Now again I will explain the steps. Same problem. In earlier problem we have seen how to handle northwest corner rule. Now here again, since the problem is same, we every time need not check. Unless and until we check whether total supply is equal to demand, we cannot proceed, that we know. So now from available matrix, what this least cost method says, from matrix identify the cell with minimum cost first. As the name indicates, least cost method. So cell with minimum cost. Cell with minimum cost. It is also called as method of inspection. So amongst these, now your job is to don't check values of the supply and demand for minimum cost. Cost is these are cost values, 12 values are cost values. So amongst these, if you find minimum is 8, so for 8 which is in S3D2, your supply is 18, demand is 8. So what you will do, as explained in previous, allocate 8, cross off, nothing remained, modify it as 10, 18 minus 8, 10 is remaining. Now very important step. Once this D2 is exhausted, you must immediately cross off this particular column. Would it have been row exhausted, immediately cross off that particular row. Very important step. Why? Sir, why this is to be done? If you don't cross off that particular column or row, there are chances that you may allocate if there is minimum value in that particular cell. to avoid that mistake, I am insisting immediately cross off. So now these values will not be considered in my least cost method for allocation. I will only consider the values these three, and these three, only 9 values. Got it? So now 19, 70, 40, here minimum is 10. Minimum is 10. So for this 10, supply is 7, demand is 14. So we will allocate 7. Immediately we will modify 14 as 7 remaining, and immediately we will cross that exhausted row. Why? That I have explained. That now we will not consider these row values. Now our values of interest are only 6. 1, 2, 3, 4, 5, 6. Amongst these 6, minimum is 20. For this 20, demand is 7, supply is 10. So I will write here 7. I will satisfy demand. I will cross off this. Immediately I will cross off column. I will make it this 3. Supply 3 remaining. Now only values with us are these 70, 40, 40, 70, 4 values. So again minimum is 40. So 40s are available at 2 places. You can take any one. So for this, suppose I select this 40, it is 7. I will allocate 7. This will vanish, and this will become 2. So now you can see, students, second row, second column, third column, fourth column are cross off. Only cells remaining are this cell and this cell, and the values which we are having are 2 and 3. So no need to apply any method. Simply allocate 2 here, cross off this, allocate 3 here, cross off this. You have made this demand. By allocating 3, you made it 2, and by allocating 2, you made it 0. Our cross check: 7, 2 plus 7, 9, 3 plus 8, 11, plus 7, 18. Column wise, 3 plus 2, 5, 8, 7, 7 plus 7, 14. So by this least cost method, I got my solution as minimum cost Z is equal to, again the same rule, 7 into 10 plus 2 into 70 plus 7 into 40 plus 3 into 40 plus 8 into 8 plus 7 into 20 is equal to, total cost comes to be, product of this is rupees 814. You can try it with the calculator. This will give you values 814. Remember the initial solution for the same problem by northwest corner rule. There we got more than 1000, 1015. Here it is 814. Initial solution I am saying, it is not final solution. So we have moved one step ahead. So this is how you find initial solution by least cost method. And now we'll see how to calculate initial solution by VAM. That is very important. Now see here, same problem. What I will be doing first, I will be writing this data for understanding, and then we'll be switching for allocation, and we'll be studying how to allocate by WAM. So here the methodology is third method, that is Vogel's approximation. Third method is Vogel's approximation method. I will explain all the steps and accordingly we'll perform each and every step. So what we'll do, we'll first write the matrix in bigger form. So here this is we have to have 1, 2, 3, then 4, 1, 2, 3, 4. Now these are D1, D2, D3, D4. This is S1, S2, S3, and these values I will write 19, 19, 30, 50, 10. Intentionally I am writing in bigger font. 70, 30, 40, 60, then 40, 8, 70, 20. And importantly, here it is supply. Supply is 7, 9, 18. Demand is 5, 8, 7, 14. So what are the steps? Steps for WAM. Steps for WAM. First, find difference of minimum and next minimum value for rows and column. This is the step. How to proceed, that I will explain now. This difference indicates penalty. Other name of difference is penalty. So how to find this difference? Is this let's use this color. So for first row, minimum is cost value is 10, next minimum is 19, difference is 9. For second, minimum value is 30, next minimum value is 40, difference is 10. I think you are getting now. For third row, difference is minimum value is 8 and this next minimum is 20, so difference is 12. Similarly, what I have written, find the difference of minimum and next minimum values for rows and columns. Rows is over, now we will find it for column. We will find the difference for column, and in that 19 is minimum, next is 40, it's 21, it's 21. Then minimum is 8, 22. Now there may be question in your mind, sir, suppose minimum is 8 at two places. So go by this wording, minimum and next minimum, 8 and 8 difference 0. Here minimum is 40, 50, difference is 10. Here minimum is 10, next minimum is 20, difference is 10. Now what I have said, what is the interpretation of this difference calculation of the cost value is, differences indicates penalty, additional penalty if we do not follow that particular route of transportation. Got it? This is also called as VAM method, or other name is method of penalty. Other name to VAM is method of penalty. Method of penalty. These differences are nothing but penalty, and you know that nobody is interested in paying penalty. Penalty is burden. So that is the reason why penalty word is used. It is burden. So we have calculated these penalties. So for set of first difference for the row and column, identify which particular row or column is indicating largest penalty. Got it? It is not only from row or column. Out of row and column, identify which is largest penalty. So here students 9, 10, 12, here 21, 22, 10, 10. So amongst these 7 values, the largest is 22. So I am marking it by arrow, indicating this is the largest penalty for first allocation. What is the objective function of transportation problem? Minimum cost. So what we'll do? We'll, after selecting the row or column with largest penalty, in that we'll find minimum cost sale. This is identified column. In this column you are having cost value 30, you are having cost value 30 and 8. Which is minimum? 8 is minimum. Now once this is decided, the same logic as we did for northwest corner rule or least cost method, out of these two allocate minimum. So here I am having 8 and 18, so I will allocate here 8. Since this is allocated complete, I will cut this and I will cross off this particular column. Immediately I will modify this supply as 10, 18 minus 8, 10. This is first step. Once you did it, again, now what is the purpose of crossing is, I will not consider these values. If I won't cross, probably I may commit mistake of considering these values. Again find difference. Now keep one thing in mind, that if you cross off, common sense, it is common sense, if you cross off column, difference of other columns remains same. So don't waste your energy in finding the difference. It will be same 21, it will be same 10, and it will be same again 10, since this is cross off. But students, this will change. This has to change, because these values are no more in picture now. Very important step, how to save time while solving problem. So now minimum is 10, next minimum is 19, difference is 9. Okay, minimum is 40, next minimum is 60. See, I am not considering 30 because this is exhausted. By chance, if you don't draw this line, you may commit mistake of taking this as next minimum or minimum. So now, since the line has gone, don't consider this value, difference is 20. I think it is now very clear, and this is the place where student commit mistake. Next is difference of minimum, next minimum 20. So repetition, identify the row or column with largest difference. 9, 20, 21, 20, 21, 10, 10. So this is largest. Once you identify this largest, identify in that minimum. Why minimum? Because our objective function is minimize. In minimum value in this first column is 19. For 19, see demand and supply 7 and 5. So you have to allocate 5. You have to allocate 5. 5 will vanish. Immediately draw cross of line. Immediately modify remaining supply. Now again repeat the same process of finding the difference. So this will remain same 10. This will remain same 10. Now these first two rows are over. So we will be finding difference of these two. It is 40. It is 20. It is 50. So you are with 40, 20, 50, 10, 10. As the process says, largest is 50. Largest penalty is 50. For 50, identify minimum value. It is 20. For 20, compare these two values 10 and 14. So you will be allocating 10. You will be allocating 10. 10 is vanished. This row has cross off. This will become 4. Now you are having 2 rows, 2 columns. Now since the row has been crossed, next difference will be same 40. Here it will be 20. And for column now difference may change. It is difference of these two 10 and it is difference of these two 50. Now 40, 20, 50, 10, largest penalty is 50. Got it? Same process we are applying. For 50 minimum is 10. So minimum is 10, 10, 2 and 4. So out of these 2 and 4 you will allocate 2. This will vanish. This will remain 2. This row will go off. Now students, only 2 cells are remaining, that is 40 and 60. No need to carry out any process. Allocate remaining in that particular 2 cells. This is allocated, vanish. This is allocated, vanish. Cross check. This is very important check. I am every time saying cross check whether you did allocation or not. So with this, what you will do is 5 plus 2, 7, done. 7 plus 2, 9 is done. 8 plus 10, 18 is done. 5 done. 8 is done. 7 and 2 plus 2, 4. 4 plus 10, 14. So how to write Z minimum? For this case, total minimum cost Z is equal to, same manner, 5 into 19 not plus 2 into 10 plus 2 into 10 plus 7 into 40 plus 2 into 60 plus 8 into 8 plus 10 into 20. If you multiply this on your calculator, you will get rupees 779. So we have seen three methods for finding initial solution. First method we have seen northwest corner rule, second least cost method, third very important WAM method. And if you compare the initial cost by three method, in first case it was 1015, in second case it was something 814, and now here it is 779. So we got for the same problem three answers of initial solution. In exam or wherever you apply this concept, in exam particularly, you are not supposed to find unless and until asked initial solution by three method. Only you have to find initial solution by any one method. I have already told that if nothing is mentioned, find initial solution by WAM. Now this problem will make you very clear that why I have insisted on WAM. So amongst the three method, only WAM method gave us least cost. If you compare three cost, WAM method gave us least cost. And now we'll check whether this particular solution is optimal or not, whether this is further possible, whether this cost can be further optimized, or this is the end cost. That we'll check. From next lecture we'll go from this, we'll take this as a reference and we will go for optimality test of transportation model. In that we will be studying modified distribution method in detail. We'll solve the same problem till end, means we'll be covering all aspect of finding initial solution, understanding why that particular solution is important, and optimizing the given solution by Modi method. Got it? So till that time you practice the problems pertaining to this dimension, this domain, and in next lecture I will proceed with modified distribution method. So here we will stop our today's lecture.